As you can see, this is my blink LED game. The game is the light travels across several LEDs. When it hits the green LED, you try to press the button. If you press a button, your score increases. So as you can see here, every time the button gets pressed when it's green LED, the score is updated and you gain a point. This is the Blink Blink Go LED game code. It's fairly straightforward as far as code goes. These are my pinouts, variables, just one more pinout, and this is the button state variable. So that's just setup stuff. Nothing active. Then we move on to the LEDs turning on and then off. So each chunk here is the LED turning on, waiting for a set amount of time, which is a variable declared up here, then turned off again. This little math section at the end of each just speeds it up. No, actually adds more time, so it slows it down. Just adds a little bit more time, so when it gets to the end, it has a bit of more transition. Each piece of code is for each LED, so this is for the 7th LED, 6th LED, 5th LED. Once we get to the 4th LED, we get this fun piece of code. Now, what this does is there's a while loop that the condition is end time minus start time. Now, what is that? So start time is it gets its value based off a function millis, which milliseconds is a function that derives how long the Arduino has been powered on for. Alright, and so we can use this function anytime we want to check how long it's been powered on for. We use it twice, for the start time and for the end time, so the end time is continuously updated. So that end time minus start time eventually will be more than 300, or equal to or more than 300, which is the condition for this while loop. Within this while loop, we get button state reading, and we turn on the LED. Now, if the button state is low, which means if the button is pressed, we increase the score, print out the score, and break from this while loop and move on to the next LED. If this doesn't happen, it's simply after 300 milliseconds, we'll continue on to the next LED anyways, but your score will not be updated, or you just won't get more points. Continues throughout the LEDs, and then switches direction. So it just goes back the other way. Starts with LED 1, goes 2, 3, 4th LED, same piece of code, same amount of time, same thing going on, same score updating. We can check the serial printouts and see what's happening here. So serial printouts, these numbers here are just speeds like the amount of milliseconds in between each LED. And why I have this is just so I know how fast it is. Now, see, I've already been playing, for a little bit, so that my score is already 7, 8, 9, 10. You know, those are my serial printouts. It's mainly just speed and score. Okay, so here's my fritzing and schematic. So first, let's start where this is my fritzing and schematic. So first let's start with ground, which is where all the outputs end up. This is ground. Ground. On the breadboard, it's this blue. So this wire and this blue side, this blue line is all ground. Second thing is this button. This button or switch shorts the current so it completes the circuit, and current is sent through this little miniature circuit right here. The change in current is detected by this port number 12, through this wire I'm clicking on. The change in current that's being detected sets off all of the code, which is with the blinking LEDs and whatnot. Yeah. Then the LED array is quite simple. It looks complicated, but it's really just one simple circuit, just done 7 times and combined in a slightly efficient manner. So first, it's easier to see on the schematic. First, each LED system is connected to an output. There are 7 outputs, or the 7 LEDs are connected to 7 outputs. So when the board sets out voltage, first the voltage is met by a 100 ohm resistor. There's a resistor over here, same resistor on the board or on the breadboard. Then it is passed through, a resistor resists the current, so only the necessary amount is being sent to components. Okay, so this sets out a certain voltage. We need to resist that current, or we need to resist the voltage just so that we don't screw up any of our components. These light emitting diodes need 100 or need a resistance from a 100 ohm resistor. So then the voltage is sent through a light emitting diode. A light emitting diode is a diode, and a diode is a one-way valve, and a light emitting one emits light when current is being passed through it. Then after is grounded, so to complete the circuit. It's just that 7 times. Over here it looks complicated, over here it's fairly simple. You can just see it. The only change is this middle one right here is a green LED, which is what the whole game is kind of based upon. And that is my fritzing and schematic.